Guys, today we're going to start with our third and final of the fundamental gas laws. This is Gay-Lussac's law, and Joseph Gay-Lussac describes what happens to pressure as we increase temperature. And you should be able to think of this one. This is one that we have a lot of experience with. This is why they say not to put a aerosol can near heat, because inside the can is a fixed volume of gas. And as you increase the temperature, the pressure is going to continue to build, so much so that we risk an explosion. This is also what happens when we use a pressure cooker. When we increase the pressure inside of a pressure cooker, we allow the temperature to raise much higher than typically our temperatures can raise when we're cooking on the stove. So because of this, Gay-Lussac's law, it looks like Charles' law. It solves mathematically like Charles' law. It's the one that we probably have the most personal experience with in terms of having gases at a fixed volume in our life is the most common thing for us. And so because of that, Gay-Lussac's law is probably going to be the easiest to comprehend. Officially, Gay-Lussac's law says that the pressure of a fixed mass of gas, that means like a steady amount, held at a constant volume, so same amount in the same size container, the pressure varies directly with Kelvin temperature. So as the temperature goes up, the pressure will also rise. That's what proportional means. Remember, proportional means when one goes up, the other goes up. So as the temperature goes down, the pressure will also go down. Okay, so that's the fundamentals of Gay-Lussac's law. What we're going to do now is we're going to look at the derivation of Gay-Lussac's law, and it's very similar to the derivation of of Charles' law. So Gay-Lussac's law is very similar to Charles' law in that we are still mapping a straight line right here. We're mapping this nice straight line. And so just like in Charles' law, we can do a little sample math problem to see that if we look at a pressure of 3 atmospheres, and we bring that over to our line and then we bring it down, it will be 3 atmospheres of pressure at 300 Kelvin. So we would see 3 atmospheres of pressure at 300 Kelvin. And then we would see 4 atmospheres of pressure at 400 Kelvin. And what we're seeing is a pattern to our ratio, right? We can imagine that if I go back and look, which we're going to do in just a second, if I go back and look at 2 atmospheres of pressure, we're expecting 200 Kelvin. So let's go back and confirm that that's what we see on our graph. So we're going to come back to 2 atmospheres of pressure here. And sure enough, here we come down to 200 Kelvin. So we see this ratio remaining the same slope of the line, same rise over run, just like we saw in Charles' law. And so because of that, we can derive a relationship between pressure and temperature that sets us up to be P1 over T1 equal to P2 over T2. Now, what we're going to do is we are going to take this law, Gay-Lussac's law, and we're going to try some problems that use Gay-Lussac's law. So what I'd like you to do is set up for your notes to be ready to write down these sample problems on your whiteboard or on your paper as I'm putting them on my whiteboard. Okay, so I'd like you guys to get ready for that. So here are our Gay-Lussac problems. Okay, so what we're going to see here, we're going to read these problems. So before from New York to Boston, the pressure in an automobile tire is 1.8 atm at 20 degrees Celsius. So when I start my problem, I need to read, okay, the pressure is 1.8 atm. So P1 equals 1.8 atm. And this pressure is at a temperature of 20 degrees Celsius. So T1 equals 20 degrees Celsius. And now, just like Charles' law, when I see a pressure of 20 degrees, or sorry, when I see a temperature of 20 degrees Celsius, I need to immediately change that to be Kelvin. So remember, to change it, we add 20 plus 273. So I'm going to do 20 plus 273 gives me 293 Kelvin. That is my temperature 1. At the end of the trip, the pressure gauge reads 1.9 atm. So that is a second pressure over here, 1.9 atm. And we are supposed to find T2. What is the temperature at that point? So now that we have our setup, we come over to our U's, and it says we're in a tire. When we're in a tire, that's going to keep our volume pretty constant. A tire will keep our volume constant because it doesn't expand very much. And it says assume tires with constant volume. It tells us that. So V is constant. So here we need to choose a law that has pressure and temperature in it, but not volume. So that's going to be Gay-Lussac's law. P1 over T1 equals P2 over T2. We plug into that pressure 1.8 atm over T1, 293 Kelvin. Always be sure you're in Kelvin. You have to plug in Kelvin. Equals pressure 2, 1.9 atm over T2. Expect it to be warmer or colder than 293 Kelvin, given the pressure change. So remember that when the temperature goes up, the pressure also goes up. So since my pressure is now higher, I'm expecting a number higher than 293. And once again, we're going to solve this using cross multiply. So 293 times 1.9, 293 times 1.9, and then we divide by our last piece, divided by 1.8, and I get 309.28. T2 equals 309.28 Kelvin. Is that a higher temperature? Yes, it is. Is that what I expected? Yes, I did. So now I feel pretty good about this answer. I feel good about boxing it. I feel good about writing it in the box on the test. I make sure I keep 2 decimal places, and if I'm typing, I put a space between the pressure value or the temperature value and the units. Okay, to make sure I'm getting credit on my Google form. Okay, so we're going to try the next one here. And so in this one, again, these are all pretty straightforward, straight shooting problems. Okay, so no problem. So let's look at it. So for the second one, we're going to start by reading at 120 degrees Celsius. So if I'm looking for P1 and T1, I have 120 degrees Celsius. And so of course we immediately change that to be our Kelvin temperature. So 120 plus 293 equals 413 Kelvin. Okay. And this has a pressure of 1.07 atm. The pressure now, or the temperature now rises to 205 degrees Celsius. 205 degrees Celsius, which 205 plus 293 gives me 498 Kelvin. And so now, again, plus 293 to get that. So now I can plug that in. I have P1 over T1 equals P2 over T2. I end up with 1.07 ATM divided by 413 Kelvin equals P2 divided by 498 Kelvin. So again, I'm going to plug this in with the cross multiply. This time a cross multiply is going to be these two multiplied together and then divide by the last one. Or sometimes people like to divide these two and then multiply by that one. That's the same math. So what I do, I always multiply my diagonal and then divide by what's left. So I'm going to do 498 times 1.07 and then divided by 413 to give me a new pressure of 1.29 ATM. So two things I want to check. One is my unit correct? Yes, my unit should be the same one that I started with in pressure. And two, is it what I expected? So my temperature did rise, and if my temperature rises because they're proportional, I expect my pressure to rise. And my pressure did go up, so I feel, again, pretty confident writing this down. Remember, the Google form will mark you wrong, so it's important that you take a minute to check with yourself, does this make sense to me? Is this the correct answer before you go ahead and put it in, okay? All right, there's one more to do, and this one does something that we see a lot in these kind of problems. It asks you for the final temperature in Celsius. So I'm going to go ahead and get rid of this, and we're going to solve our last one together before we're done with new progress before spring break. Okay, so last problem here. We've got a sample of helium gas has a pressure of 120 atm. So my P1, 1.20 atm. My temperature is 22 degrees Celsius, T1. So I'm going to put in 22 degrees Celsius. But remember, I want to change that immediately to be in Kelvin. So I'm going to do 22 plus 273 equals 295 Kelvin there. And then at what Celsius temperature? So it wants us to answer in degrees Celsius. In what Celsius temperature will the helium reach a pressure of 2 atm, 2.00 atm? So the big thing here is to make sure that once I've solved my temperature, I remember to put it back into Celsius. And so I like to put a note to myself there so that I don't forget, because remember, it marks the whole thing wrong, you know, if you get that one part wrong. So we're going to do P1 over T1 equals P2 over T2. And then we're going to go ahead and plug in. So I'm going to have my 1.20 atm divided by my 295 Kelvin is equal to 2.00 atm divided by T2. So now what I'm going to do is solve, and we're going to do our cross multiply here. So multiply those and then divide. So I'm going to do 295 times 2 and then divided by 1.20 gives me an answer of 491.67 Kelvin. And so remember that at this point, it's really important to recall that this is not the answer to type into your Google Sheet. It's important to remember that we need degrees Celsius. So we subtract minus 273, and I end up with 218.67 Kelvin. And just one more reminder to keep your 2 decimal places and also to put a space between the 7, oops, not Kelvin, uh, degrees Celsius. Whew, degrees Celsius, because we subtracted our 273. Now, one last thing about degrees Celsius is that Google Form does not support adding degrees Celsius. So if you were to put this unit on the test, you would put in 218.67 space and then just a C, because I don't believe that it supports entering the degree Celsius. So on a test or quiz, you could do just the C. All right, that's it for today. Talk to you guys later.